Okay, hi everyone, welcome back to my YouTube channel, theMathAficionado. Today's video is going to be the first video on the course of Pre-Algebra and the first, I would say, the chapter which was discussed. I have discussed the list of the chapters corresponding to this course in my previous video, so you can do check out that video. I'll put the link in the bio or the description. Now, having said that, so this is going to be the video on the very first topic in the pre-algebra, and that is introducing to the algebra. Okay. So as you can see, there are total of 6 lessons in this chapter, which is Introduction to Algebra. And these lessons are, the first one is operations in the correct order. The second one is evaluating the expressions. Third is identifying the properties. Identifying the properties. Fourth is the equations with the variables. Equations with the variables. Fifth one is coordinate system and ordered pairs. Okay, so this is coordinate system and ordered pairs. Sixth one would be inequalities. So these are the list of the 6 lessons that we have as a part of this chapter, which is Introduction to Algebra. Okay, so we'll be covering these lessons one by one in this video. I'll make sure to cover that in detail with theory as well as examples. Okay, so let's start with the first lesson, which is operations in the correct order. Okay, so here in this case, what do we understand from a mathematical expression? So mathematical expression basically involves the several operations over parentheses. Okay, so the order of operations is what matters when the multiple operations are involved in a mathematical expression. Okay, so whenever we see a mathematical expression having multiple operations, so that is where the order of the operations do matter. Okay, how do we perform the operations, which operations take the precedence is what matters. Clear? I'll give you the example. So let's say if we have 4 times 7 minus 2. Now here you see that there's a multiplication operation in between 4 and 7, and there is a subtraction between 7 and 2. Correct? So these are the multiple operations that we have as a part of this mathematical expression, right? Okay, so now how do we perform these operations? Do we perform the subtraction first or do we perform the multiplication first is what we are going to see, and what makes us decide that is also we are going to see. Clear? Okay, so now here in this case multiplication is going to take the precedence over the subtraction. Okay, so you can take it for this for now. So I'll be giving you the the order of the operations in the order of their respective precedence. Okay, but in this case I can say that the multiplication is going to be taking the precedence. So here 4 times 7 is going to be 28, and then we are performing the subtraction. So that is going to give us 28 minus 2, and that is 26. Okay, now suppose if this would have been otherwise, let's say if we perform the subtraction first and multiplication later, so we will see how this is going to change the answer. Clear? So when I say the subtraction is going to be first, so that means we are going to subtract 2 from the 7, and then whatever the result comes up, that gets multiplied with 4. Okay, so 7 minus 2 is 5. When gets multiplied with the 4, so that is going to give us 20. Now you can see that the answer, which was the first one, and that is 26, is now different from the 20, right? So that's what I was intending to convey, that the operations, how do we perform them, in what order does matter. Okay, so here as we have seen that if we perform the multiplication first, we are getting the answer of 26, and when we perform the subtraction first, so we do get the answer of 20, which are two different answers. Now how do we avoid this confusion, which one is right and which one is wrong? How do we take the order of the operations? Okay, for that, in mathematics we do have the standard order of operations. So there's a specific standard that we follow while deciding which operation is to be performed first. Clear? Okay, so what is that standard operation? What is that standard order of operations? Okay, before that I would like to tell you that this standard order of operations will be applicable in the case of mathematical expression involving multiple operations. Clear? So this standard is only applicable when we have a mathematical expression involving multiple operations. Okay, it's obvious, because if we are only having one operation, so then it doesn't matter which, because we eventually have one operation, so it doesn't matter which order we are following, right? Now what is the order that I'm talking about? What is that standard order that we have been talking about? So the first one that comes at the top in the terms of precedence is we simplify the expression inside the parenthesis, brackets, braces, and fraction bars. Okay, so the first precedence is taken by the parenthesis, brackets, braces, and fraction bars. Second one is evaluation of the powers and exponents. Okay, so whenever the exponents are concerned, so that takes the second precedence. The third one is doing all the multiplications and divisions from left to right. So here in the third precedence, we perform all the multiplication and divisions, but what we have to keep in mind is they are performed from left to right, not right to left. Okay, so in this case it is always going to be left to right. Similarly, in the fourth one, we are going to perform all the additions and subtractions from left to right. Okay, so here again we perform from left to right. Clear? So this is the standard order that I was talking about, wherein the 4 different precedences are set. Okay, now I'm going to give you example. Okay, the example here is how many hours a person works in 2 days. Assume that they work 5 4 hours they work 4 hours before lunch and 3 hours after lunch each day. Okay, so this is the problem statement that is given to us, wherein we have to figure out how many hours a person works in 2 days, correct? And what is given to us is they work 4 hours before lunch and 3 hours after lunch every day. Clear? So how do we calculate this now? So now how much or how many hours the person works in 2 days is what is supposed to be figured out. Now in order to cover the number of hours a person is working in 2 days, we will first have to find out how many hours the person is working for 1 day. So that is what is supposed to be figured out first. So person works for a total of 4 hours before lunch and 3 hours after lunch. So that is 4 plus 3, and that is 7 hours every day. Okay, so this is the number of the hours that he is working or she is working in 1 day. Clear? Okay, so now in order to calculate the same thing for 2 days, so we are going to multiply this by 2. So 7 is going to be multiplied by 2. Okay, what is 7 here? 7 is the work done in 1 day, and since we are supposed to figure out for 2 days, so we are going to multiply this 7 by 2. Okay, so this 7 is going to be multiplied by 2, and that is going to give us 14 hours. So for 14 hours is pretty much the work done by the person in 2 days, and that's your answer. I hope that's clear. Okay, what was 7 in the first place? 7 was number of the hours the person worked for in 1 day. Okay, and we multiplied that with 2 in order to get 14. Okay, so this was your example on the same. Now here, how do we represent this situation in terms of mathematical expression wherein the multiple operations are involved? So we are going to write it as 4 plus 3, which was your work done in, or the number of the hours the person worked for in 1 day, multiplied with 2, which is your number of days. Okay, so this is how we are going to represent the same situation or the given situation in the form of a mathematical expression involving multiple operations. Okay, what are those multiple operations? The addition between 4 and 3 and multiplication between the 7 and 2. Clear? And what did we solve here? First we solved the parenthesis, which is outside of 4 and 3, right? And the result of that is multiplied with 2, which is your second precedence, right? Parenthesis is your first precedence. That is how we apply the standard order of operations in order of the respective precedence. Now let's see another example. Here we are given 2 times 8 minus 3 plus 6 times 2. And then there is minus 3 outside. Okay, so we will first figure out how many operations and what are those operations. That's the part of this given mathematical expression. Okay, now as you can see the mathematical expression, so what are the operations that's here in this mathematical expression? So the first operation that I'm able to see is the subtraction between, okay, sorry, not subtraction, rather we will first focus on the parenthesis out of 8 and 3 and also out of 2. Okay, then there is a subtraction outside before 3, then there's a multiplication between 6 and 2. Okay, then there is a subtraction between 8 and 3, then there's a multiplication after 2 in front. Okay, and the last is the outside, then we have addition between 8 minus 3 and 6 times 2, and the last is the brackets, which are the outside square brackets. I hope you are able to visualize all the operations that's being the part of this mathematical expression. Now we will follow that standard order of operations and we will figure out the answer to this by making use of the right precedence and right order of applications of these operations. Clear? Okay, so what comes first out of all the operations that we have here? What do we start with? How do we simplify this expression, or you can say the mathematical expression? So the step one here is going to be, okay, so as you studied, what was the first precedence in the order? So that was solving all the brackets, parentheses and braces, right? So here, what are the brackets, parentheses and braces? So we have first one as 8 minus 3. So that is what is going to be solved first, which is going to give us 5. Then the another one parenthesis that I see here is outside of 2, which gets multiplied with 6, and that is going to give us 12, right? So 6 times 2 is going to give us 12. So these are pretty much the parentheses that we have. I know we have brackets outside, but that we are going to simplify in the next step. Okay, so the next step is going to be the addition of 5 and 12. So that is what we are doing, is we are simplifying the outer brackets. Okay, we are performing the operations inside the brackets, and that gave us 17. Now this 17 we are okay, in the step 3 we are trying to get rid of this bracket, and this 17 gets multiplied with 2 in order to give us 3, and that subtracts 3 in front, and that is going to give us the final answer as 31. Okay, so this is your order of operations in the terms of their respective precedence. Okay, that's being applied here, and we eventually figured out the answer as 31. Clear? So this was your first lesson, that was operations in the correct order. Now we are going to cover the next lesson, which is a part of this chapter, is evaluation of expressions. Okay, so we are starting off with the second lesson, which is evaluation of expression. I hope the first lesson is very much clear to you. Okay, so now let's write down the lesson number 2, which is evaluation of expressions. Okay, so when I say expressions, obviously the expressions will have the variables as well as constants, right? So what do we understand from the variables? Variable is any letter, like sometimes we assume the variable to be x, y, z, or any letter of, or any alphabet for that matter. Okay, so that is what we understand from the variables, right? And what do the variables represent? So they basically represent something, or you can say the value which is unknown, right? So what do the variables represent? Is they represent a value which is unknown to us, okay, which is not known to us. That is what we call as variable. Clear? So we represent something which is not known to us, or the value which is not known to us, with a variable. That's our understanding of the variable. Correct? Okay, if I have to give you example based on a variable, so how would I give that? Let's say your example is going to be something like this. So let's take 6 plus x is equal to 12. So this is your algebraic expression. Okay, now what is variable here and what is constant? So 6 is a constant, 12 is a constant, but what is x? X is a variable, and that represents the unknown quantity which we are supposed to figure out and make it known. Correct? Now what should be added to 6 so that you get 12 on the right? What should be added? I just repeat, what should be added to 6 on the left so that I get 12 on the right? Okay, so it's obvious. We should add 6 to the 6 on the left so that we get the right 12. Okay, so what is x then? X is 6. Okay, so we have figured out the unknown, which was x, to a known value, which is 6. I hope that's clear. Okay, now this was a hidden trial, by which we solve the value of x. Now how do we generally solve it in mathematics? So here we have 6 plus x on the left and 12 on the right. So we are going to move 6 to the right. So on the right now we have x is equal to 12 minus 6, and that is equal to 6. So your value for x is 6. Clear? This is how we evaluate an algebraic expression. This is how we evaluate an algebraic expression. Okay. So the next we are going to calculate the following expression for x is equal to 3 and z is equal to 2. So here as you see that we are going to evaluate an expression provided we are given the value of x as 3 and z as 2. Okay, so we are already given the value of these two variables. Now what is expression here? Expression here is 6z plus 4x, and that is what we are supposed to figure out the value of. Okay, so now here we will be substituting the respective values. So x will be substituted as 3, z will be substituted as 2. So that is going to give us the value as 6 times 2 plus 4 times 3, and that is 12 plus 12, which is 24. Right, so the answer to this expression is 24. Clear? So this is how we make use of the values of variables. I mean, I've shown you both the examples wherein the first we were calculating the value of a variable, in the second we were substituting the value of the variables in the given expressions and finding the value of the expression. Okay, so that is your usage of variables in terms of expressions. Okay, I'll give you one more example wherein instead of 2 variables we'll be having 3 variables for which the value of them are given, and we are supposed to evaluate the expression based on those values. Okay, now what are the values of the variables that is given to us? X is given as 2, y is equal to 5, and z is equal to 4. We have to make use of these values of the variable to evaluate the expression, which is 4x plus 7 minus z minus 6y. Clear? So this is the expression and the value of the respective variables are given to you. Now let's substitute them and figure out the value of expression. Now what is x? X is 2. So that is going to give us 4 times 2. Right? So first we are going to substitute x as 2. So that is going to give us 4 as that is going to give us 4 times 2. Next is z is 4, so that is going to give us 7 minus 4, and y is 5, so that is negative 6 times 5. So 4 times 2 is 8, 7 minus 4 is 3, and 6 times 5 is 30. So that is going to give us 11 minus 30, which is, because 8 plus 3 is going to give you 11, and then there is a minus 30, so that is 11 minus 30, and which is negative 19. That's your answer. Okay, so here we do get the value of negative 19 as the answer to this expression after substituting the values of the variables, which are x, y, and z. Okay, so this was your lesson number 2. I hope the concept of a variable and how do we substitute the value of the variable in the expression, and also how do we evaluate the variable based on the expression is clear to you. Now we'll be moving to the third lesson, which is identifying the properties. So we are going to start with the third lesson, which is identification of properties. Okay, so let's see lesson number 3, that is identifying the properties. Okay, so when I talk about the properties, so what do I understand from the properties? Which properties we are talking about here? So we are essentially talking about the properties of the operations. As you have seen, we have multiple operations: addition, subtraction, division, multiplication. So what properties do these operations follow? Okay, how do we perform these operations? Okay, and what properties are basically followed while performing these operations? That is what we are going to see as a part of this lesson. Okay, clear? Let's take the example 58 plus 69 plus 91. Now here we see the three numbers being added together. Okay, and we have to evaluate the value of this addition. Okay, or you can say the result of this addition. So now here, as we know that in addition the order doesn't matter, right? In which order you are adding the numbers when the multiple numbers are involved. So here, instead of 58 plus 69 plus 91, if I write it as 91 plus 58 plus 69, so does that matter? No. Eventually they both are going to lead us to the same answer, which is 218. Okay, so this clarifies that in addition the order doesn't matter. The order is, I mean to say by the order is in which the operations or in which the numbers are added. Which numbers comes first, which comes after, it doesn't matter. Okay, so now we have seen this in the case of addition. So what else is the operation where the order doesn't matter? So the other operation that is where the order doesn't matter is multiplication. So in both addition and multiplication, these are the operations where the order doesn't matter. These are the operations where order doesn't matter. And on the other side, when we talk about the subtraction and division, that is where the order definitely matters. That is where the order definitely matters. Clear? So when we talk about addition and multiplication, it doesn't matter. But on the other side, when we talk about the subtraction and division, it does matter. For sure. Okay, so we'll see the example. We have already seen the example of addition. Now let's see the example of multiplication. So let's say if you have three numbers in multiplication, which is 5, 4 and 30. If we change the order in this case, and let's perform it as 4, 30 and 5. So what are the answers that we are getting in both the cases? It is 600. So you can see that again in the case of multiplication, we are leading to the same answer. Okay, irrespective of the order that we follow in the multiplication. Right? Does that make sense? I hope that makes sense. Clear? Okay, so now the next we have seen that subtraction and division is not going to follow the order, or you can say the order will matter in that case. So let's see why. So first I'm going to take the example of the subtraction, then we will take the example of division. Okay, so when the subtraction is concerned, so let's say if we take the example of 10 minus 4 minus 3. Okay, and now when I change the order and the same numbers are changed to 4 minus, it's not 10 minus 3, we change it to 4 minus 3 minus, so we change it to 4 minus 3 minus 10. Okay, so in the first case, since we know that in the case of in the case of addition and subtraction, we perform it from left to right. So this is going to give us 10 minus 4 as 6 and 6 minus 3 as 3. In the second alteration, so this is going to be 4 minus 3, which is 1, and 1 minus 10 is going to give us negative 9. So you see the order of the numbers has eventually changed the answer in this case. So that means the order does matter in the case of subtraction, right? So the order does matter in the case of subtraction. Now let's come to the division, where again the order is going to matter. Okay, let's take the example of 10 divided by 2, and which is further divided by 5. Now when 10 is divided by 2, so that is going to give us 5. Okay, so let me remind you that in the case of division also we follow the operations being performed from left to right. So 10 divided by 2 is going to give you 5, and then there's another 5. So 5 divided by 5 is going to give us 1. Now when I change the order of the numbers, let's say if I write it as 2 divided by 10 divided by 5. So now 2 divided by 10 is going to give me 1 over 5, and which is further divided by 5. Now when I change the division in between the 1 and 5, 1 by 5 and 5 to multiplication, because that's how we solve a division. So the other number goes reciprocal, and now the answer turns out to be 1 over 25. So you see here again, when we change the order of the numbers, the answer changed. So that means the order of the order of the numbers does matter in this case as well, right? So subtraction and division, the order does matter. Addition and multiplication is when the order doesn't matter. Okay, so this was your concept of the lesson number 3, which was evaluation of expressions. Okay, so this, not evaluation of expressions. Lesson 3 was all about identifying the properties. Okay, so the next is our lesson number 4, wherein we are going to study equations with variables. Okay, so if you go to the list of the lessons that we discussed in the beginning of this video, okay, wherein we had 6 lessons as the part of this chapter. So the 4th lesson is equations. So the 4th lesson here is equations with the variables. Clear? So that is what we are going to start now. I hope the first 3 lessons are clear to you, and now they make sense to you as well, right? So the lesson 4 here is equations with variables. We'll be seeing the equations wherein the variables are involved, and how do we solve these equations, okay, and what is the concept of inverse operations, because here we are going to study about the inverse operations for each operations that we are aware of, okay, and how do we make use of these inverse operations to solve the equations. That is what essentially the brief of this lesson. Okay, so what did it tell you, what we are going to study as a part of this lesson? Okay, as the name itself suggests, equations with variables, so that means definitely the equations are there and also the variables are there, right? So what we are going to study at the part of this lesson is, we'll be solving these equations. And how do we solve these equations? So there will be 2 different scenarios. One is without the inverse operations. I'll come to this, what is inverse operations, in a minute. So here we'll be solving the equations in 2 situations, one without the inverse operations and one is with inverse operations. Okay, when I say without inverse operations, so that means the normal way we solve the equations. Okay, and with inverse operations, obviously that is going to involve the inverse operations. Okay, now let's take the example of 8x equals 64. Now how do we normally solve this equation? So as we have seen in the first lesson, so what do we do is, either we do a hit and trial, wherein we figure out what should be multiplied in the 8 with the 8 on the left to get 64 on the right, so that is obviously 8. Or in the other words, or in the other way, if I have to solve this, so I'll move the 8 to the right in the division. So x is equal to 64 over 8, and that is going to give me 8. Obviously they both are correct ways of solving. Generally we adopt the second way, okay, because hit and trial is a bit complicated and may take some time to solve the equation. Okay, the another example that I'm going to take here is, so the other example is, which of the following numbers is the solution of the equation. Now what is the equation here? Equation here is 14 minus x is equal to 7. Now we have to figure out which of the following is the solution to this equation. Okay, so this is the equation, 14 minus x is equal to 7. Now when I say which of the following, so what are the options? X is equal to 2, x is equal to 7, and x is equal to 8. Okay, so these are the options that's given to us, and we have to figure out of them which one is the solution of this equation. Now what we are going to do is, we are going to evaluate this equation for each of the option. So first is x is equal to 2, so we'll evaluate by substituting x as 2. So that is going to give us 14 minus 2 is equal to 12. But on the right hand side we had 7, so they are not equal. So definitely this is not going to work, or you can say that this solution is not satisfying the equation, right? The next is x is equal to 7, so 14 minus 7, which is equal to 7. Now that is equal to the right hand side, which is again 7. Okay, so this solution definitely is the solution to the given equation, or you can say this option is the solution of the equation. The third is, we are going to verify with x is equal to 8. Now 14 minus 8 is basically 6, and that is definitely not equals to 7 on the right. So the only option that is making sense to us as a solution of this equation is x is equal to 7. Clear? So we have figured out here that if we are given the different options and the equations, so we can clearly find out by substituting each option that which option satisfies the given equation. Okay, so that is what we have studied so far. Now the next we are going to study is, what is inverse operation, as we have seen above, right? Because this lesson is all about the two scenarios with and without the inverse. So without inverse we have already seen just now. Now we are going to see with the inverse operation. So in order to study with the inverse operation, we have to first understand what exactly is inverse operation. So that is what we are going to discuss next. Now when I say the inverse operation, so that is something, the operation that reverses the effect of another operation. Okay, so that reverses the effect of another operation. So when I say reverses the effect of another operation, what does that mean? So for example, let's take the example of two operations which are addition and subtraction. Now we know that when something is added, so what is going to reverse that? Obviously the subtraction, right? So we can say on the basis of this that the addition and subtractions are the inverse of, or are the inverse operations to each other. Okay, so subtraction is going to inverse the effect of, or reverse the effect of addition, and addition is going to reverse the effect of subtraction. That's what makes them the inverses of each other. Clear? Now what was next? Multiplication and division. Now they both are also the inverses of each other. Why? Because division reverses the effect of multiplication, and multiplication reverses the effect of division. So that's what makes them the inverse to each other. Clear? So this is what we understand from the inverse operation. So I'll just repeat. Inverse operation is an operation that reverses the effect of another operation. So we have seen that subtraction is the inverse of addition, addition is inverse of subtraction. Similarly multiplication and division. I'll show you the example. Example here is 18 plus 4 is equal to 22. Now here what is there? What is operation involved? So that is addition on the left, right, between 18 and 4. Now in order to reverse the effect, or in order to reverse this addition operation, what I'm going to use? I'm going to definitely use the subtraction, because I know that the subtraction is the inverse of addition. So let me use the subtraction here. So subtraction here is 18 plus 4 minus 4. So now we have used subtraction as the inverse of addition. So now when I use inverse, so I use it on both the sides, okay, so that we can balance out the equation. Okay, so I have subtracted 4 on both the sides, making it using it as the inverse operation. Okay, so now when I use 4 subtraction both the sides, so that is going to eventually lead me to 18 equals 18. That means left hand side is equal to right hand side, and that definitely makes sense, right? In order to prove an equation, or in order to prove a specific value as a solution of the equation, we do equate left and right at the end of the step. Okay, and that validates that whatever we were figuring out, or whatever we were validating with, was correct. I hope that's clear, right? Okay, let's take the next example of x plus 4 is equal to 22. So here what is the operation involved? So operation here involved is addition, right? Operation here involved is addition. So now as we know that the subtraction is the inverse of the addition, so that means we are going to use the inverse of the addition, which is subtraction. So x plus 4 minus 4 and 22 minus 4. So we have used this negative, or the subtraction inverse, on both the sides, and that has led us to x equals 18. Okay, so what did we do here is we solved the equation for the variable x by making use of the inverse operation, which is subtraction. Clear? Now we have seen the example of subtraction and addition being the inverses to each other. So now we have also studied that there are two more operations which are the inverses of each other, and that is multiplication and division. Now we are going to see the example on that, and that will mark the closing of this lesson. Okay, so the next example I'm going to take is on the multiplication and division being the inverses to each other. What is the example here is x times 2 is given as 10. Now obviously there's a multiplication involved between x and 2, correct? And now we know that division is inverse of multiplication. So we are going to divide by 2 on both the sides, making use of division as the inverse operation. So I'm going to divide by 2 on both the sides of the equation. Okay, so what did we make use of here is we use the division as inverse for the multiplication, and that is given as x is equal to 5, and that's how we have solved the equation. Clear? So division here is used as the inverse of multiplication. Okay, so now this is the end of lesson number 4. The next lesson here is lesson number 5, which is coordinate system and ordered pairs. coordinate system and ordered pairs. Now many of you must be familiar with the coordinate system, right? To some extent you must have studied the pairs of x and y, right, wherein x denotes your x coordinate and y denotes your y coordinate. We do represent that as a part of a 2D coordinate system. Okay, so that is essentially what we are going to study here in this next lesson, which is coordinate system and ordered pairs, and this is our lesson number 5 as a part of this chapter. Clear? Okay, so what is coordinate system? Coordinate system is a two-dimensional number line. Okay, so when I say number line and two-dimensional, so two-dimensional obviously makes it to the something which is in 2 dimensions, right? Obviously there's going to be one in horizontal and one in the vertical domain, correct? Now when we say the horizontal, so that is definitely represented with x, and when we say vertical, that is represented with y. So vertical axis is represented with y. So essentially we have two axes, one is horizontal axis and one is vertical axis. That's what makes it 2D number line, okay, or two-dimensional we can say. Now here we have two perpendicular axes or lines, right? Now I'm going to discuss in detail how do we represent the axes, how do we represent the quadrants, how do we represent the positive negative x-axis and positive negative y-axis, also how do we represent a point on a 2D coordinate system, okay, and in which quadrant what are the signs of the x and y. Everything we are going to discuss. Now as you can see, so the first quadrant is the first section, second is second, and then third, and then fourth, okay, as you can see on the screen. Okay, so this is your coordinate system, or you can say this is how we draw the coordinate system, which is a 2D system. Now this is your positive x-axis, then this is your positive y-axis, okay, then we have negative x-axis, and then last we have negative y-axis. Okay, so we have 4 segments basically: positive x-axis, positive y-axis, negative x-axis, and negative y-axis. Now the next we study about the origin point, which is 0 0, which is basically the intersection of both the axes, which are horizontal and vertical axis, or you can say x and y axis. So the intersection point of these two are origin, which is 0 0. Now when we write it in the form of 0 0, the first 0 represents the x coordinate of the origin, the second 0 represents the y coordinate of the origin, okay, or you can say the x value of the point and the y value of the point. Clear? Now let me label the points on all the axes. So 1 to 6, then it is 1 to 6 on the vertical, then we have 1 to 6 on the negative side, which is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Similarly, this is going to be in the negative y-axis as well, which is vertically downwards. Okay. Now when I talked about origin, which was 0 0, so I mentioned that the first 0 corresponds to the x coordinate of the point. Okay, or you can say the x coordinate of the origin, or you can also say that as x value of the point, right? Similarly, the other 0 is indicating the y coordinate. We also call that as y ordinate and the y value of the point. Okay, and I've also labeled this point as a part of the coordinate system. Clear? Now that point is corresponding to the intersection point of both the axes. Now let's say there is one point which is point A, and the coordinates of this is 1 2, where 1 is x and 2 is y. Obviously here 1 2 is going to fall in the first quadrant because they both are positive, right? So when x and y are positive, so that point falls in the first quadrant, which is Q1. Okay, so the first quadrant is when your x and y both are positive. How do we represent this on the coordinate system? So that is what you can see on the screen. Okay, so it is the intersection from the vertical point starting from 1 on the x and horizontal line starting from 2 on the y, and wherever they meet is your point number E, which is 1 2. Clear? So this is how we draw a point on the coordinate system. Similarly, let's take point B, which is negative 1 2. What is x here? Negative 1. What is y here? 2. Now here x is negative but y is positive. Now which quadrant should it fall in? It will fall in quadrant number 2, because as we can see on the screen, quadrant 2 is formed by the negative x-axis and positive y-axis. So that means in the quadrant number 2, x is negative and y is positive. So negative 1 2 will fall in the quadrant number 2. Okay, so the first point was falling in quadrant 1. Now this one is falling in quadrant number 2. Now let's take the example of another point, which is a third point, and that is point C. Now here it is negative 2 and negative 1. Now we see that both x and y are negative in this case. So when both x and y are negative, so that is a part of which quadrant? That is a part of quadrant number 3. Why? Because quadrant 3 is formed by both the negative x-axis and the negative y-axis. So whenever they both are combined, so that is what that is what forms the quadrant number 3. Clear? So our point C is going to fall in the quadrant number 3. Now when I talk about the line, so line as in when x is constant, or you can say, you can take the example of x being 1. So whenever such situations arises, so this is simply denoting a line which is parallel to y-axis. Why? Because x value is constant. So when x value goes constant, so that is corresponding to a line which is parallel to y-axis. I'll show you with the black color on the screen. Okay, so this is a line which is x is equal to 1, and that is going exactly parallel to the y-axis. Clear? Similarly, there will be another case when y is equal to constant. And now what does this correspond to? This corresponds to a line which is parallel to x-axis. Okay, why? Because y value is constant here. So this will form the line which is parallel to x-axis. Okay, I'll show that as well on the coordinate system. Okay, so this is again shown in the black color. As you can see on the screen, we are drawing the line which is y is equal to 1, and that is a horizontal line parallel to x-axis. Clear? So this is y is equal to 1. Now when I say x is equal to 1 and y is equal to 1, so it's clear to you what lines do they represent. Now if I ask you what does x is equal to 0 and y is equal to 0 represent on the coordinate system, so now it should be clear to you. X is equal to 0 is what? The y-axis, the horizontal, the vertical axis that we talk about. Okay, and what is y is equal to 0? That is your x-axis, the horizontal axis that we talk about. I hope that is making sense now. Okay, and if someone asks you the equations of x and y-axis, so you can easily tell y is equal to 0 and x is equal to 0 respectively. Okay, so this was all about the coordinate system and the ordered pairs. Okay, so now when I say the ordered pairs, okay, since we have not talked about the ordered pair, so when I write a point in the form of x and y, okay, as we have seen the origin being written as 0 0, so that is what the ordered pair is. Okay, wherein there is an order of x being written first and y being written after. Okay, so any point which is being represented in the coordinate system, so that is always represented as a ordered pair. Clear? Now let's move to the lesson number 6, which is inequalities, and that's the last lesson of this chapter. Okay, so this is the last lesson of this chapter, and then we'll close for today. We'll be covering the next chapter in the next video. Now the lesson number 6 that we are going to study is all about inequalities. So this is all about inequalities. So we did talk about equation. Now we are going to talk about inequalities. Before that, I've just made it clear to you. I'll also write it on the screen. What was ordered pair in the past, in the last lesson? So ordered pair is the way we have represented the different points A and B, A, B and C. Okay, so here when a point is represented in the form of x and y, so that is what is ordered pair. I hope that's clear and there should not be no doubt. There should be no doubt regarding this. Okay, so when I write the point as 2, 3, so here this is what the ordered pair is. This is what the ordered pair representation of the point is. Clear? Okay. Now let's start the next lesson, which is lesson number 6, and that is inequalities. Now when I write x is equal to y, so obviously that's equation, right? We have already talked enough about the equations. So what does this equation represent? X is equal to y. If I have to write that in words, so what is equal here? Equal is a symbol, right, between x and y, and that is what is representing the equality between the two, correct? And that's why we call this as equation. Now suppose instead of equality comes up an inequality. Now it can be in any form, whether it is greater than, equals to, greater than, less than, equal to, or less than. Okay, so it can be any inequality. Suppose if inequality comes in between these two, so that is when we write that as an inequality. Okay, I'll give you the example. Now let's say if the inequality involved is greater than, so we would write it as x greater than y. Now this is inequality based on greater than. If it is greater than and equals to, so we will be writing it as x greater than equals to. If it is less than, so x less than y, and then last is x less than equal to y. Okay, so these are 4 essential inequalities that we study about. Okay, so the first one is greater than, the second one is less than, the third one is greater than or equals to, and the last one is less than or equals to. Okay, so third one is greater than or equals to, and the last one is less than or equals to. So these are the four essential inequalities that we are going to talk about. Okay, so I hope the difference between equation and inequality is clear to you now. Okay, I'll write that in words. Okay, so an equation or inequality that contains an equation or inequality that contains at least one variable, as we have seen in the examples above. So an equation or inequality which contains at least one variable is called open sentence. Is called open sentence. Okay, so it's called open sentence. When you substitute a number for a variable in the open sentence, when you substitute a number for the variable, or you can say in place of variable in an open sentence, so the resulting statement is either true or false. What does that mean? So when you substitute for the variable in an open sentence, so either the result is going to be true or false. So when it is true, what does that mean? That means the number that you substituted for the variable is the solution of the equation or inequality. Okay, why I'm writing both? Because open sentence is formed from either of them. Okay, so it can be equation or inequality. That's why if it turns out to be true, so that means it is a solution of that equation or inequality which formed the open sentence. Clear? Okay. Now we'll see a few examples to justify what we have studied so far in this one. Okay, so I'm going to take the example. Example here would be, is 3 a solution to this equation? That's your first example. Okay, so is 3 a solution to the equation? What is the equation given to us is 5x plus 14 is equal to 24. What is x here? X is variable, right? So x here is variable, correct? So what we are going to substitute in place of x, since we are verifying 3 is a solution, so we will substitute x for 3. So when we substitute x for 3, so we are going to get 5 times 3 plus 14 on the left, which is 15 plus 14, and that is 29, right? And on the right we had 24. So are they equal? No, they are not equal. So what can we say about this? It is, since it is not equal, that's why it is a false open sentence. Now this open sentence was all about equation, not inequality, right? And we verified that 3 is the solution of this open sentence, or you can say of this equation, right? Similarly, we are going to see the open sentence as an inequality in the next example. Okay, so this was your example for the open sentence based on equation. Now the next we are going to say is the open sentence based on inequality. So the next example is going to be the open sentence based on inequality. Okay, so what is example here is, so the example here is the following inequality true or false? Okay, what is inequality that is given to us is x minus 4 is greater than 12. Okay, so this is inequality. Now what is inequality here is greater than. Okay, now what we are going to check for, what we are verifying it for, x is equal to 13. So that means obviously we'll be substituting x for 13 in the given inequality the way we did for the equation. So 13 minus 4 on the left and 12 on the right. So 13 minus 4 is 9 and 12 is on the right. Okay, so is 9 greater than 12? Because we are getting 9 on the left and 12 was already on the right, and then there is a greater than sign in between them. Correct? So 13 minus 4 is 9 greater than 12. Is that true? No, that is false. That is obviously false. Okay, 9 is definitely less than 12. So what can we say about this? That x is equal to 13 is not a solution of this inequality, or you can say the open sentence. Why? Because here open sentence was based on an inequality. In the last example we had open sentence based on equation, right? So whenever it turns out to be true is that when the solution is, otherwise it is not. Now here it didn't turn out to be true, so that means x is equal to 13, not a solution of the given inequality. Clear? Is not the solution of this inequality. So I hope this is clear. I'll take one last example, which is y plus 5 less than 13. Now we have to verify for y is equal to 6. Now what is different here from the previous example? In the previous example we had greater than inequality. Now here we have less than inequality. So when we substitute for y is equal to 6, so 6 plus 5 on the left, that is 11, and which is less than 13. Now this turns out to be true for sure. Okay, now when this turns out to be true, so we can say that y is equal to 6 is the solution of this inequality, or you can say the open sentence. Clear? So I have taken example of all the cases when it was an equation and that turned out to be false, right? I have also taken the example of an inequality where it turned out to be false, and the third one was I have taken the example of an inequality where it turned out to be true. Clear? So this was all about the lesson number 6, which was a part of this chapter. Okay, so now in the next video I'll be covering the next chapter, which is exploring and understanding the integers. This was the first chapter, that is introduction to algebra. The next chapter is going to be, which is in the coming video, and that is exploring and understanding the integers. I hope you like this video. Okay, that's all for today. If you found this helpful, please don't forget to like, share and subscribe to my channel. I really appreciate if you do this. Okay, your support is what motivates me to keep creating such content with the love and dedication. Okay, I would love to hear your thoughts and let me know in the comments how you like this video, and if you have any suggestions, please do let me know in the comments, and so that I can improve. Okay, so that I can improve my content, my videos, and I can create the best I can for you guys. Okay, so that was all, and thank you so much for this. Okay, I'll see you in the next video with the next chapter of Pre-Algebra. Okay, so I'll see you in the next video with the next chapter of Pre-Algebra. Okay, so this was interesting, right? So we had roughly 1 hour of video on the first chapter. Okay, and I'm trying to minimize the duration of the videos. If it exceeds a specific duration, so we'll split that into 2 parts if required. Okay then, thank you so much. Please don't forget to like, share and subscribe to my channel, the Math Aficionado.